Welcome to today's deep dive. And I want to start by just having you think about your day for a second.
Yeah, just kind of picture where you are right now.
Right. Because you likely spend the vast majority of your life inside buildings.
Yeah.
Sitting at a desk, relaxing in your living room, or maybe just wandering through a grocery store.
Most of us do.
But how often do you actually stop and think about the light illuminating your space? Like, is it flat? Is it dynamic? And most importantly, where is it actually coming from?
Probably not very often. I mean, until the power goes out, right?
Exactly. So today's mission is a deep dive into excerpts from Derek Phillips' 2004 book, Daylighting: Natural Light in Architecture.
Which is really a fascinating read.
It totally is. We're going to guide you through the bizarre history of humanity's attempt to completely banish natural light indoors.
Yeah, that did not go well.
Not at all. We'll look at why that incredible hubris backfired spectacularly and the architectural science of bringing the sun back into our lives.
It's a journey, for sure.
Oh, absolutely. By the end of this conversation, I guarantee you are going to look at every single window you pass in a completely new way.
I mean, the architectural journey of the window is essentially this centuries-long quest to invent a transparent shield.
A transparent shield. I like that.
Yeah, because we are looking at this wild intersection of structural engineering, human biology, and just environmental reality.
Right.
You start with early humans in caves, right? And the opening is just a crude hole.
Which lets in light, sure.
It lets in light, but it all brings the weather with it.
Rain, freezing cold.
Exactly. And predators. So the goal was always to sort of separate the light from the elements.
Makes sense.
And the Romans made a massive leap by using these small panes of hand-blown glass, but they set them into heavy bronze frames.
Wait, bronze frames. That sounds intense.
Very heavy, very clunky. But then you jump forward to 17th century England, and manufacturing advances finally allowed for genuinely large glass panes.
So suddenly a window isn't just a tiny porthole anymore.
Right. It becomes a substantial feature of a room. And by a modern movement of the 1930s, structural engineering had advanced so much that steel frames carried the weight of the building.
Not the walls themselves.
Exactly. So that meant architects could build entire curtain walls of glass.
Wrap around corners, all of it.
Yeah, fundamentally blurring the line between the indoor and outdoor worlds.
Okay, so we finally mastered the window, right? But then we hit the 1960s, and the story takes a massive, slightly dystopian turn.
It really does.
Because up until the early 20th century, daylight was the absolute primary means of lighting any building. If you didn't have sunlight, you just couldn't work.
You'd have to go home.
Right. But as the workplace grew and electric light sources became cheaper, a massive cultural shift happened. Enter the utility companies.
Ah, yes, looking to aggressively increase electricity sales.
Exactly. They began pushing for unbelievably high levels of artificial light. Like in the United States, they were recommending levels of up to 1,000 lux for standard office spaces.
Which is...
For context, for you listening, a cozy living room in the evening is maybe 50 lux.
Right.
A brightly lit grocery store aisle is around 500. And they were telling companies to blast desk workers with 1,000 lux of flat artificial glare for 8 hours a day.
It was an entirely engineering-led approach. It completely disregarded daylight as a functional source of illumination.
Like it didn't even matter anymore.
Basically, the prevailing belief was that electricity was so incredibly cheap and fossil fuels were so infinitely abundant that artificial light would inevitably supplant natural light.
Which is crazy to think about now.
Totally. Derek Phillips actually quoted his own earlier work from 1964 where he ironically predicted that natural lighting was becoming a pure luxury.
A luxury, like we wouldn't even need it.
Exactly. And this line of thinking is exactly what led to those windowless factories and massive windowless office blocks.
And the schools, right.
Yes, windowless schools, which the source material calls the ultimate idiocy.
I mean, locking kids in a windowless box all day.
Engineers genuinely toyed with the idea of heating massive corporate buildings entirely through the ambient heat generated by these massive 1,000 lux artificial lighting rigs burning all day long.
Okay, let's unpack this. Because it's as if we invented a synthetic vitamin pill and arrogantly decided we never needed to eat real food ever again.
That is a great way to put it.
We just thought, hey, we have this powerful artificial substitute, so let's just bulldoze the entire concept of the sun.
Yeah, the hubris is wild.
The sheer audacity of these 1960s architects believing they could just effortlessly replace something the human eye and brain evolved under for millions of years is just wild to me.
Well, the illusion of cheap energy shattered in the 1970s anyway.
The energy and oil crises,
Exactly. They hit the global economy hard. Suddenly, the realization dawned that fossil fuels were a finite, politically volatile resource.
and burning them at that reckless rate to power 1,000 lux lighting grids was economically suicidal.
Not to mention severely damaging to the environment. So that crisis forced an abrupt pivot back toward passive architecture.
We basically had to remember how to harvest the sun.
Right, we had to drastically reduce the electricity load. And this historical blunder actually birthed the modern concept of net zero energy demand.
Which is what, exactly?
It's the foundational idea that a building should ideally only consume as much energy as it can harvest on site.
Oh, wow.
Yeah, it stands as the ultimate corrective response to the engineering hubris of the 1960s.
So the energy crisis forced corporate management to bring windows back simply to save money on fuel. But delving into the biological data from the sources, it becomes incredibly clear that we are actually physiologically starving without them.
We really were.
The return to daylight wasn't just about saving fuel, it was about saving ourselves.
If we connect this to the bigger picture, humans possess a deep biological necessity for visual rest centers.
Visual rest centers.
Yeah, and the psychological reassurance of knowing the weather and the time of day. Daylight provides two vital psychological anchors for the human brain orientation and variety.
And without those anchors.
The mind just struggles to process its environment.
Which brings up the 1970s Hong Kong shopping centers perfectly. They completely illustrate the psychological toll of removing those anchors.
Oh, the windowless mall.
Yeah, developers built these massive, labyrinthine windowless malls to maximize retail wall space.
Because windows take up valuable shelf space.
Right. But people inside experienced extreme spatial disorientation. Shoppers literally panicked because without the shifting angle of the sun or a view of the outside world, they couldn't figure out where they were.
Or what time it was.
Exactly.
Yeah.
Or how to find the exits. It induced severe claustrophobia.
I can imagine.
But then you contrast that with City Plaza, which was another massive Hong Kong mall built around the same time, but constructed with massive overhead daylighting spanning multiple stories.
And how did that go?
It was an immediate, massive success. People lingered longer because they felt anchored to the real world.
Because beyond mere orientation, daylight gives our physical world meaning through a concept called modeling.
Okay, what's modeling?
Modeling is how directional light plays on three-dimensional forms to give them shape, texture, and depth.
Ah.
Because artificial light in an office is almost always flat and static, right? It just rains down from a perfectly even grid of overhead fluorescent tubes.
It's just a wash of light.
Exactly. It obliterates shadows. But daylight, especially streaming in from a vertical side window, gives light a vector. It comes from a single dynamic direction.
Think about a Greek Doric column, with those deep vertical grooves carved into the stone. Or Michelangelo's David in Florence.
Or the ancient bronze charioteer statue at Delphi.
Right. If you put those masterpieces under a flat grid of fluorescent office lights, they look entirely dead.
They lose their math entirely.
But under daylight, the shadows slowly, almost imperceptibly, shift across the marble and bronze as the sun tracks across the sky. The light is actively, continuously sculpting the form throughout the day.
And that dynamic changing quality is precisely what our retinas and our circadian rhythms actually crave.
And when we don't get it,
When we are deprived of that subtle variety, the health impacts are severe and measurable. I mean, Vitruvius, the ancient Roman architect, was writing extensively about the absolute necessity of healthy, naturally lit building sites in the 1st century BC.
he knew it intuitively way back then.
Exactly. And today we have clinical names for ignoring Vitruvius's advice. We see seasonal affective disorder and sick building syndrome.
Which is awful.
Yeah, where poor, static, flickering artificial lighting causes chronic eye strain, tension migraines, and severe lethargy.
Which really brings us to the staggering economic irony of the windowless office.
Oh, the cost breakdown is wild.
It is. The annual lighting cost to power the artificial grid around a single desk worker equates to roughly 3 to 4 hours of their actual salary.
Just 3 to 4 hours for the whole year.
Yes, it is a rounding error in the corporate budget. So ruining a worker's productivity, destroying their health, and tanking their mood with bad windowless lighting just to save a few pennies on the electricity bill, it's a massive financial failure.
It is the absolute definition of a false economy. Human beings are a company's major operating expense and their greatest asset.
That's right.
If the workplace is visually impaired, physiologically stressed, and losing their sense of time due to their environment, their cognitive output plummets.
Right.
The savings on the utility bill are entirely wiped out by the drop in productivity.
But I have to challenge the corporate logic of that era, though.
Go for it.
If humans evolved as hunter-gatherers under the shifting, dynamic, chaotic light of the sun, why did mid-century management ever believe that a static, unchanging, artificially lit box would somehow optimize human concentration?
It stems entirely from the industrial mindset of treating human beings like manufacturing equipment.
Well, like a machine.
Exactly. A mechanical loom or a stamping press operates best under perfectly constant, unchanging conditions.
Because variations in temperature or light cause mechanical tolerances to drift.
Right. And corporate management mistakenly mapped that exact factory floor logic onto the human brain. They genuinely believed that eliminating the changing variable of daylight would eliminate visual distraction.
But that's not how our brains work.
Not at all. They failed to realize that the human brain habituates to static environments. It actually requires that subtle, continuous environmental variety to remain alert, maintain focus, and stave off neurological fatigue.
Wow. So if daylight is both a biological and economic necessity, we have to look at how architects actually capture it without ruining the core function of the building.
Yes, moving from the why to the how.
Right. We know why we need the sun, but how do we engineer its delivery?
We have to examine the architecture of light and the actual physical mechanics of the window itself. It is all about how you frame the view and manipulate the photons entering the space.
Here's where it gets really interesting.
Mm-hmm.
Because we tend to think of a window as just a dumb hole in the wall filled with a sheet of glass, right?
Usually, yeah.
But the 18th century Georgian window was actually a finely tuned optical lens deliberately designed to actively manage the flow of light into a room.
The Georgian window is an absolute architectural marvel of subtlety and optical physics.
How so?
Well, the builders used splayed edges.
Splayed edges.
Yeah, meaning the interior plaster wall doesn't meet the glass at a harsh 90-degree angle.
Okay.
Instead, the wall tapers and angles outward from the window frame into the room.
Oh, so it's not just a boxy cutout.
Exactly. And this wasn't merely a decorative flourish. It actively graded the light, softening the harsh, blinding contrast between the extraordinarily bright outdoor sky and the much darker interior wall.
That's so smart.
Furthermore, they used incredibly thin, meticulously crafted wooden glazing bars to hold the small panes of glass together.
The little grid lines you see on old windows.
Right. These bars were so refined and narrow that the incoming daylight would actually wrap around them due to the scattering of light.
Really? It would just wrap around.
Yeah, effectively minimizing their shadow and preserving an uninterrupted view of the outside world.
Contrast that optical brilliance with the windows we build today. Because of modern cheap mass production, we constantly use these clunky, heavy, thick timber or vinyl sections that completely block the sightlines.
They cast heavy, highly distracting shadows across the room.
It's as if we completely unlearned the optical physics of the 18th century just to make manufacturing slightly easier.
Sadly true. But as structural engineering allowed corporate buildings to grow massive, consuming entire city blocks, a beautiful Georgian side window simply couldn't reach the center of the floor plan.
Right, light only penetrates so far.
Exactly. People in the middle of these deep plan buildings were plunged back into darkness.
So what was the fix?
The architectural solution to that problem was reviving and modernizing a Roman concept, the atrium.
Oh, I'd love a good atrium.
The modern atrium is the direct evolution of the open Roman courtyard and the classical domed roof.
So deep plan commercial buildings use these elongated glass-roofed atriums essentially as internal daylit streets.
Yes.
It's a brilliant neurological trick. Even if the actual measurable foot candles of light hitting the ground floor of an atrium are technically quite low, your eye sees that massive vertical column of daylight stretching up to the sky.
And it instantly tricks your brain into feeling connected to the outdoors.
You just don't feel trapped in a bunker.
It is highly effective, but it requires incredibly precise spatial dynamics to work.
Like what?
Think of a deep atrium like trying to light the bottom of a deep well with a single flashlight.
Oh, okay.
The ratio of an atrium's width to its height completely dictates whether that sunlight actually reaches the pedestrians on the ground floor.
Got it.
A wide, shallow atrium performs beautifully, flooding the lower levels with ambient light. But a narrow, incredibly tall atrium, like you see in some towering hotels, might leave the ground floor in perpetual depressing gloom.
Which kind of defeats the entire purpose of the structure.
Exactly.
Windows aren't just functional conduits for photons. They are highly communicative.
Oh, absolutely.
The symbolism of how an architect frames the light dictates how you experience the room. Like, look at the modern extension of the Boxmoor Church.
Right, that's a great example.
It boldly uses the physical structural window frame itself to form a massive, glowing Christian cross. The light and the theology are physically merged right there.
It is powerful.
Contrast that with Le Corbusier's iconic church at Ronchamp.
Yeah.
He designed walls that are incredibly thick, and he pierced them with deep, irregularly scattered tiny windows.
Yeah, it creates a highly specific, deeply symbolic, almost mysterious interior light.
It feels ancient and solemn. The window literally tells you how to feel about the space you are standing in.
But once you have designed the perfect window and you have successfully invited the glorious sun inside, you immediately face the architect's greatest, most relentless adversary.
Which is?
Solar heat gain. Letting the light in brings a dangerous, invisible stowaway. The infrared energy of the sun turns a glass building into an absolute oven.
Yeah, nobody wants to work inside a greenhouse in July.
Exactly. So the entire second half of daylighting architecture is figuring out how to filter the light from the heat.
So we enter the relentless battle of solar shading. And from the source, you basically have two distinct operational choices: external shading or internal shading.
Right?
External means using architectural louvers, massive concrete canopies, or deep overhangs. You physically stop the heat before it even has a chance to touch the exterior glass.
Which is thermodynamically superior because the heat never enters the building envelope.
Makes total sense.
But once you put a giant rigid canopy or a set of metal louvers on the outside of a towering skyscraper, you've just created a massive sail.
Oh, a sail. Because of the wind.
Exactly. It catches heavy wind, driving rain, and snow. They degrade quickly and are incredibly dangerous and expensive to maintain at height.
So architects realized the only practical way to protect the shading mechanisms was to bring them indoors.
Right, behind the glass. Which forces us to look at internal solutions like curtains and blinds.
Which brings us to the surprising redemption of an often maligned tool, the Venetian blind.
People hate on them so much.
They do. The Venetian blind gets such a bad rap as this dusty, annoying, purely utilitarian office fixture that always gets tangled.
It's true.
But it is actually a highly flexible, highly sophisticated architectural marvel. If you have a Venetian blind in your office or home right now, you can try this.
Oh yeah, the tilt trick?
Yes. When you tilt the slats correctly, you can do two critical things at the exact same time. The upper slats can be angled upward to reflect the incoming daylight deep into the room.
Bouncing it off the white ceiling to softly illuminate the back of the space.
Exactly. Meanwhile, the lower slats can be angled down to completely block the direct, blinding glare and harsh heat from hitting the person sitting right next to the window.
It is remarkably elegant when used properly.
It really is.
And engineers have pushed these exact light-bending concepts even further into innovative physical systems.
Like light shelves.
Yeah, light shelves,
Yeah.
which are essentially solid, horizontal overhangs placed partway up a tall window.
So they function similarly to the blind.
Exactly. They allow you a clear, unobstructed view out the bottom half, while the highly reflective top surface catches the high summer sun and bounces it deep onto the ceiling.
And what about light pipes?
Those are cool. They're highly reflective, mirrored tubes installed in roofs. They physically capture sunlight on the exterior and funnel it down through the attic to illuminate dark, windowless domestic spaces.
Like interior hallways or bathrooms.
Right.
My absolute favorite application of this light manipulation is prismatic glazing.
Oh, Richard Rogers' work.
Yes. The architect Richard Rogers used this beautifully at the Billingsgate Fish Market in London when he converted the historic building into a modern computer center.
It's a fantastic adaptation.
The glass actually features microscopic ridges that use optical refraction to physically bend the harsh, direct sunlight away from the workers' computer screens.
So it totally eliminates the blinding glare on the monitors.
Exactly. While still flooding the expansive room with ambient natural light, it bends the light exactly where you want it.
What's fascinating here is that the true bleeding edge of this battle against solar heat gain is no longer happening with bulky overhangs or metal blinds.
Where is it happening?
It is happening at the microscopic chemical level right inside the glass itself, We are rapidly moving into the era of high-tech automated glass.
Like photochromic glass.
Right, which darkens automatically based on the intensity of the UV light hitting it, utilizing silver halide molecules much like transition lenses in eyeglasses.
That's incredible.
And there is electrochromic glass, which uses extremely thin layers of metallic ions like lithium sandwiched between the glass.
How does that one work?
When a tiny electrical current is applied, those ions migrate and physically block certain wavelengths of light and heat, turning the glass opaque.
Wow.
And thermochromic glass, which utilizes materials like vanadium dioxide to react specifically to ambient heat. It blocks infrared wavelengths when the glass gets hot, while still letting visible light through.
Okay, I have to ask a challenging question about all this incredible technology, though.
Sure.
Are we just trying to invent hyper-expensive, highly complex smart glass to fix the totally avoidable problems created by incredibly dumb, lazy building designs?
That is the big question.
Right, because if architects didn't build giant, sealed glass box skyscrapers facing the harsh western afternoon sun in the middle of a desert, we wouldn't need microscopic lithium-ion coatings to save us from boiling inside rock.
You're not wrong, and the architectural community is wrestling heavily with exactly that realization.
I would hope so.
Because the ultimate goal of building science isn't just to invent a cool, hyper-expensive gadget to slap onto a fundamentally flawed building.
So what is the goal then?
The true goal is the convergence of passive design. A genuinely sustainable building uses intelligent orientation, natural ventilation, proper external overhangs, and smart, low-tech solutions first.
Oh, I see.
The high-tech electrochromic glass should be the final, subtle polish to optimize the environment, not the fundamental crutch keeping the building habitable.
That makes a lot of sense.
The ultimate objective is to entirely eliminate the need for mechanical, energy-intensive air conditioning by deeply harmonizing the building's physical form with its specific local climate.
You know, if we look back at the journey we've just taken, it completely changes how you view the built environment.
It really does.
We started with the arrogant hubris of the 1960s, where engineers genuinely believed they could lock humans in windowless schools and artificially feed us 1,000 lux of blinding glare.
Just absolute madness.
And then we moved through the deep, primal biological craving we possess for the shifting shadows of the sun and the absolute psychological necessity of orienting ourselves in time and space.
Those visual rest centers we talked about.
Yeah, exactly. And we explored everything from the subtle optical brilliance of the 18th century Georgian window all the way to the microscopic metallic ions shifting inside modern smart glass.
Quite a spectrum.
It reminds you that daylight is never just a luxury. It isn't just a nice view to have while you drink your coffee. It is the fundamental, non-negotiable starting point of all good architecture.
You know, this journey raises an important, slightly philosophical puzzle for you to mull over long after you finish listening today.
Oh, leave us with something to think about.
Yeah. If we look toward a future where our buildings feature perfectly automated photochromic and electrochromic windows, glass that flawlessly regulates our indoor climate, blocking the summer heat, maximizing the winter sun, and adjusting the ambient light without us ever having to lift a single finger or make a single decision.
Yeah.
Do we risk losing something essentially human? If the building does absolutely all of the adapting for us, will we lose the simple, primal joy of actively choosing to open a window?
The sudden thrill of feeling a chaotic, unpredicted breeze.
Exactly, or the harsh, unmediated warmth of the winter sun hitting your face. Are we simply replacing the arrogant, engineering-led artificial lighting world of the 1960s with an equally sterile, engineering-led, automated natural lighting world of the future?
Wow. The friction with nature, the ability to control our own environment, even if it's imperfect, is kind of part of what makes us feel alive.
I think so.
Well, next time you are sitting in a room, take a moment to look closely at the nearest window. Notice the shadows, notice the direction of the light, and maybe just see if you can open it. Thanks for joining us on this deep dive.